Hello friends. So now we are going to start with very wonderful topic of Laplace transform, in which we will see the inverse Laplace transform. So here I am going to explain you what is the definition of inverse Laplace transform and what are the different formulae or the standard results that are used to solve the numericals on inverse Laplace transform. So let's start. So guys, let's start with the definition of inverse Laplace transform and then move to the formulae that we are going to use in numerical. So we will write down one formulae in inverse Laplace transform. So to understand the definition of inverse Laplace transform, let us understand the definition of Laplace transform. So in the Laplace transform, we have seen that we apply the Laplace transform on a function of t, or by using the Laplace transform, any function of t gets converted into a function of s. So I'll write it down for you. It means if I am applying Laplace transform on f of t, then we get function of s, and we apply the Laplace transform f of t means we find out the definite integral of this f of t. So its answer is phi of s. It means it gets converted into function of s. So this is what we have learned in inverse Laplace transform, and the exact reverse process I would say would happen with inverse Laplace transform. It means if we apply the inverse Laplace transform on function of s, then we will get function of t. It means if I take this Laplace transform on right hand side, that will become Laplace inverse of function of s. So if we apply inverse Laplace transform of, or if we find out the inverse Laplace transform of any function of s, then that will give us function of t. So it means guys, here in inverse Laplace transform, our question will be a function of s, and when we will find out the inverse Laplace transform, we are gonna get function of t. So this is what is the definition of inverse Laplace transform. Now let's start with the formula. So guys, it's clear that we are gonna derive, or we are gonna write down all the formulae of inverse Laplace transform from the Laplace transform itself. So let's start. So we have seen the formula. So formula number 1, I'll start with the first one. We have seen there that Laplace transform of 1 is equal to 1 upon s. So in inverse Laplace transform, what we'll get? So I'll shift this L on the RHS. That will become Laplace inverse of 1 upon s, and guys, it will give us 1. So this is the formula of Laplace inverse of 1 upon s. So one thing to note here is the function on which we are applying inverse Laplace transform is a function of s, and in return we will get function of t. So 1, it's a constant, but we can consider, or we can treat it as a function of t. Next, second one. So we know that Laplace transform of e to the power at is 1 upon s minus a. Similarly here we will get L inverse of 1 upon s minus a. So I'm just shifting L inverse to here, and we will get answer as e to the power at. Now third one formula. Now this formula is exactly similar to the second one. So if we take L inverse of this 1 upon s plus a, then guys, we are gonna get e to the power minus at. Next, so guys, what I'll do is I'll write down all formula of Laplace transform, and then we'll see how it gets converted into inverse Laplace transform. So guys, here I have written all formula of Laplace transform. Now let's derive the formula for inverse Laplace transform. So here in this formula, if I shift this L inverse to the RHS, we will get Laplace inverse of this A upon S square plus A square. So guys, here I am writing 1 upon S square plus A square purposely, because when the question will come in the exam, it is not mandatory that they will give you A in the numerator. So let's say if there some number is coming, let's say 3 or 4 or 5, what you will do that time, you will take it outside, correct? So here you will get 1. So I'm considering same formula. So if I'm shifting L inverse here, and instead of A I'm taking 1, it means I'm shifting that A outside, and that A will come to LHS, and that will become 1 upon A into sine of A t. So guys, this is the formula of L inverse of 1 upon S square plus A square. Now here, if I shift L inverse to the RHS, we will get Laplace inverse of S upon S square plus A square equal to, now here we will get cos of AT. Now I'll use the same method as formula number 4 in formula number 6, that is I'll find out L inverse of 1 upon S square minus A square. So I'm not considering A, it means A will go to LHS, and that will become 1 upon A hyperbolic sine of AT. Next, here we will get L inverse of S upon S square minus A square equal to hyperbolic cos of AT. Now guys, let's understand this formula carefully. So if you see here, then to find out Laplace of t to the power n, where n is integer. So guys, we generally use this formula if n is integer, because here in the answer we are writing n factorial, and we find out factorial for the integer number, that is 3 factorial, 7 factorial, 9 factorial. And whenever we get n as a fraction, we use formula number 9, because here we have gamma function, and in gamma function we can find out the value of fractions also. So now if n is integer, this is the formula. So just observe the terms. So if the power of t is n, in the answer you get n factorial, and here the power of s becomes n plus 1. It means I can say that the value in the factorial is exactly equal to the power of t, and the power of s is 1 more than the power of t. Or in the reverse language, I would say the power of s, or the power of t, I would say power of t is 1 less than the power of s. So guys, I am going to use this relation here. So here I'll write L inverse of 1 upon s to the power n. Now guys, see carefully how I am changing this formula. So here we have seen the relation that the power of t is 1 less than the power of s. So here power of s I have considered as n. So power of t becomes n minus 1. Similarly, I have not considered n factorial in L inverse, because while finding L inverse, we take L to the RHS. So it means n factorial is outside the L inverse. So it will go to LHS and it will divide here. But what we have observed, one more thing, is the power of t is exactly equal to this factorial. So now the power of t has become n minus 1. So here we will get n minus 1 factorial. Now guys, let's see formula number 9. Now again observe certain terms. So here power of t is n, whereas the number inside the gamma function is n plus 1, and the power of s is n plus 1. It means these two numbers are 1 greater than the power of t, or I would say the power of t is 1 less than these two numbers. Now I'm going to use the same relation over here. So let's find out L inverse of 1 upon s to the power n. Now guys, here the power of s is n, and here we have seen that power of t is 1 less than the power of s. So the power of t will become n minus 1. Next, what we have observed is the power of s is exactly equal to this number inside the gamma function. So since the power of s is n, inside the gamma we will get n. Now we are finding L inverse of this quantity, and in that gamma n plus 1 I have not considered, so it will go to the LHS and it will divide here, so that will become gamma of n. Now guys, why I have done these changes in formula number 8 and 9? Because in the exam you get question like L inverse of 1 upon s cube. So it becomes easier to write down the formula because you can directly say the value of n is 3. So therefore answer is t to the power 3 minus 1 upon 3 minus 1 factorial. But let's say if we are taking this formula only in the reverse way, that is L inverse of 1 upon s to the power n plus 1. Now in that case what happens, if you are getting question as L inverse of 1 upon s cube, then you have to compare that 3 with n plus 1, and that time you have to write down n as 2. So that time student makes mistake, or you don't remember at that particular time that you have to take value of n 1 less than the given value. So to remove all the complications, I generally tell to students to remember formula in this way. So now we have written 9 formulae for inverse Laplace transform, and we have seen the definition of inverse Laplace transform. And guys, based on this, now we are going to solve the different types of numericals on inverse Laplace transform. Thank you.